Hello everyone, this is Kenneth Brony from Tech and welcome back to the channel. So in this series of videos, you are learning Python, and this is specifically SENG 207 Programming for Engineers, a course taught at the University of Ghana. So if you have been following along, we have this particular structure, and this is almost like the structure or the chapters of a book. So currently, we're on chapter 14, where we are going to discuss Python sets. So Python sets is part of the Python collections, and I made mention of that when we started with lists. So let me just collapse this so that we have enough space to read everything over here. So a Python set is a collection which is unordered. So please pay attention to the keywords over here. It is unordered and not mutable. And one of the things you should also be mindful of the fact that it does not allow duplicate members. Good. So now let's see what these sets are about, and let's actually test the unordered nature of sets and also not mutable. So in order to declare sets, let's use the examples we have been using, fruits. All right. Now, if you wanted to declare a list, we use this square brackets. If it is a tuple, we use this parenthesis. Now for a set, we use this curly brackets. And the way we declare a set is the same as we declare a dictionary in terms of this curly brackets, but a dictionary is a little bit different. So currently, if I come in here and, for instance, try and print out these fruits, if I'm to run this, we get this empty something over here. And I'm saying something because if we check the type, and let's try and print out the data type over here, and if I'm to pass in fruits, this is going to tell us that this is a dict, which is a dictionary we are going to cover in the next chapter. But then if we try and pass in something, let's say an empty string like this in here, when I run this now turns into a set. So it is a dictionary if it is empty, but then a set if at least there's an element in there. And like I said, when we get to dictionary, we are going to see these differences. So basically, you cannot necessarily define an empty set as it is. At least there should be some kind of an element in there. So now let's have our fruits. So first of all, we have mango. Then we have, let's say, banana. And let's have apple. So now we have some elements in here. Now when I run this, we do get our fruits printed out over here. And clearly we see that this is a set based on the instructions we have on line 6. But pay particular attention to the order in which we presented our collection over here, or our set over here. In other words, pay attention to the manner in which we presented it, or the way we did our declaration over here. Inside of our elements, mango comes first, banana comes second, and apple. But when it was printing out, there's a little bit of change because banana prints first, mango comes in, and apple. Now when I run this again, there's a different order. Now we have apple, banana, and mango. When I run this again, there's another order: banana, apple, mango. When I run this, there's mango, apple, banana. And this re-emphasizes the fact that this Python set collection is unordered. So there is no order over here. So unlike lists and tuples, where we could confidently say that the first element, the index is 0, the second element, the index is 1, and in this case, the last element, the index is 2. Or if you have to use negative indexing, we can say -1. In this particular instance, there is no order. So this thing does not apply over here. And let me show you something. So let me just comment this one out. So this does not apply. Let me clear this. And if I decide to, let's say, print the element from index 0, if this is a list, then it's going to be mango. If it is a tuple, then it's going to be mango. Now, because this is a set, and it is a set because we are declaring this in this curly bracket, if I run this, we do get a problem over here, and it says type error. set object is not subscribable, and that's simply because there is no order over here, and for which reason we cannot put in an index to print this out. So anytime we print this out, there's going to be a different order, and that's what you see me do over here. Now, having done this, now let's look at where we have the mutability. So definitely we cannot, because there's no order, we cannot also change things in there. So for instance, we cannot do this and set it to, let's say, orange. Remember, this in itself is not valid because we cannot grab the first index because there's no order. But then if you try doing this, it says there's a type error, and it says set object does not support item assignment, and that's exactly what we see over here. So there's no order. Now let's look at the last point I have over here, and it says it does not allow duplicate members. So we cannot have an instance where, let me try adding once again banana and apple over here. Because it does not allow duplicate members, it's not going to print duplicate members over here. So now when I run this, you only get one example of each, and the duplicates are chopped off. It doesn't print them at all. So this can actually be a very good candidate to actually sort distinct items or things in a particular list. And I'm saying in a particular list in the sense that, remember what we used to do, and this is just by way of information, but then please pay attention. Remember what we used to do. If we had, for instance, x is equal to, let's say, 10, the declaration we have in x, as we have over here, x is a string. So for instance, if I'm to print out x, and I'm also to print out the data type of x, if I run this, we do get that this is a string. This we already know. And we came to an agreement that most of the time when we are using the console application, and for instance, we are using the input method or the input function, the input function will by default accept whatever thing we type in as a string. And if you want to do some mathematical arithmetic operations, we therefore need to do some typecasting. We extensively discussed this I think in chapter 8 when we're dealing with arithmetic operations. So if you are lost, kindly go back and go and do a refresher. So if you want to just change this into an int, we can simply do int. So this is what we refer to as typecasting. So we are changing the string we have over here in 10, and we are converting it into an int. So now when I do this and print this out, we do get an int over here. We can as well change this into, for instance, a float. And now when I do this, we do get a float over here. This we already know. Now we are applying that same knowledge and that same principle into doing some of the things we have over here. So first of all, let me change this back into a list, and I'll simply do so by just declaring it in a square brackets. This makes this a list. And let me just uncomment what we have over here. Now when I run this, we clearly see that this is a list, and that's what we have over here. Now I can do a typecast over here and change fruit into, for instance, maybe a set or a tuple. And that's also very simple. All that I can do is, let's say I can declare a new variable, and I'll say new fruit. And new fruit will now be equal to this fruit. And now if I change this into, for instance, a set this way, this is more or less doing a typecasting of this fruit list I have over here. Now what I'm going to do is I'm going to print this new fruit variable I have over here, and I'm also going to print out the data type of this new fruit variable. So I just copied and pasted it over here. So now when I run this, we do see that this has now changed into a set, and we have the data type of a set. Now because it had duplicate members, automatically it is taking all the duplicates off and just returning the distinct elements we have in there. And this is what I said. If for instance you have some kind of a collection which was originally given to you in a form of a list, and you just want to see distinct element in there, you can simply do a typecast and change it into a set, and for which reason you only get distinct values of the element you have in there. So this could be one of the ingenious ways you can use to manipulate data. So having gone through this, and now we've been able to satisfy our curiosity in a lot of ways, and we can do same, for instance, changing let's say a set into a list, a tuple into a set, and vice versa. I mean, the change is possible. So we've been able to demonstrate that it is unordered, it is not mutable, we cannot change things in there, and it does not allow duplicate members. So if they are duplicate members, it only chops them off and only returns the distinct values we have in there. Now let's look at some few things over here, and over here we are going to look at the union and the intersection property of sets. So let's say I have two sets, so I'm going to call this first score, and once again I need to bring in the curly brackets, and these are the scores. I have 30, I have 40, and let's say I have 50. This is for the first score, and let's have another one, and I'll name this second score. And for second score, let me say I have 20, and I have 70, and I'll do 80 over here. Now if you are doing an intersection and a union simply means we are combining all the elements we have in first score and then in second score put together to form one set. And an intersection will definitely be trying to figure out the element that appears in both sets. So let's first of all try and see if there's a new union, and indeed the union is just going to combine both. So we can simply do something like this. We can do, for instance, first score dots, and if I do a dot, you could see that these are the methods we have associated with sets. So there are quite a number of them. And let's say we do union, and you could see that we have this lookup over here. It says we can put in an iterable and it will return a set. So the iterable is something we can iterate, and that's what we are going to put in as the second score. And because this is returning a set, we can simply come out here and print it out. So I'll save this, and now when I run this, we do get a union over here. So clearly you can see that once again there's no particular order, it just put things up as we have it over here. But then let's count. We have 3 members in the first set and also 3 members in the second set, and that's exactly what we have over here. We have 3 members and another 3 members, making 6. So the union will combine everything together and give it to us. Now if, for instance, we had 30 over here, in which case 30 is now appearing in set 1 and in set 2. Because a set in itself will not allow duplicate members, it will rather put out just 130 and will not allow the other 30 to come. So in this case, the union will have only 5 members. So now let me run this, and that's exactly what you see over here. So there are only, you could see that there are 3 members over here, and there's another 2 member over here, so making up 5. And that's because we cannot have 30 and another 30. So that you should keep in mind, in as much as we are putting everything together. Because set does not allow duplicates, it's not going to allow you to have duplicate members in that set. So this is good. Now let's look at the intersection, and the intersection will basically print out what appears in both sets. So currently, if we go back to, for instance, 20, and to do the intersection, I can do, let me just comment this one out. That's also very simple. I can do something like the first score dot intersection, and I'll say second score, and I'm going to print this out, and I'll wrap this out in a print statement. So now when I run this, we do get an empty set over here, because as far as these 2 sets are concerned, there's nothing in between them, or there's no element that appears in first score set and also in second score set. But now if, for instance, this is 30 and I try to print out the intersection, we now see 30 over here. If what we had over here was 40 and I try to run this, we now see 40 and 30 being printed out as the intersection. All right, so now let me just comment what I have over here and move on to the last example we have over here, and that's with the difference method. But before I even do that, let me also show you this. There's also another way of representing the union and intersection, and let me quickly do that. So let's say we have print, and inside of this we can say first score, and when I bring this pipe character over here and say second score, this is going to be the union. So we can use this character over here to also represent union. So we want to see everything joined together, and currently as we have it, let me change this back to 70 and also change this back to 40 so that we'll have everything joined up together. So now when I run this, we clearly see that everything is joined up together. This is also the union, and the intersection, we can also use this character, this and character over here. And now when we run this, currently it is going to be an empty set because there's nothing or there's no common element between the two sets. But then if I change this to 30, save this, and now run this, we do get 30 as the intersection. All right, so this is just by way of information. Now let me just cut everything I have over here and put it down here for us to see the difference. And with the difference, it is very interesting. So for instance, let's do something like first score dot difference, and we will pass in the second score set over here. And now let's try and print this out. I'll explain exactly what is happening. Now when I do this and run this, we do get a 40 and 50 over here. So now let's hover around the difference and see exactly what this does. So this is a method, and the difference will take in an iterable. That's what we have passed in here, and it will return a set, and that's exactly what we are seeing over here. So back to the difference. Now it says returns the difference of two or more sets as a new set. Now this information is very important. It says that i.e. all elements that are in this set but not in the other sets. So that's going to be the difference. So all elements that are in first score but not in second score. So currently you could see that we have 50 and 40 in the first set, but then not in the second set, because currently there's 30 over here and there's 30 over here. So this one wouldn't be considered as part of the difference. So the difference is what is in this set and not in the second set. Let me hover my mouse over here. It says all elements that are in this set but not in the other set, and it is actually going to check the iterable you pass in first. So now we are doing a difference of first score and second score. So it is a first score set that's going to be the differentiating factor. Now if we do the same thing and say second score dot difference, and we pass in first score over here, let me comment this one out, and we try and print this. If we run this, we do get the difference, and once again the difference of this set that is not in the other sets. So the difference of second score, and for second score we could see that we have 70 and 80 that is not present over here, because 30 is present. The difference is 0 over here, and in this case it is only 70 and 80. All right, now there are other methods that I believe you can try your hands on, do your own experimentation and see what it does. So for instance, when I do a first score dot, you see that I have add, I have clear, I have copy, I have update difference and things of that sort. And you could see that the names over here are quite intuitive, and if some of the methods we discuss in the other Python collections are anything to go by, then you can clearly see that, for instance, if you do add, the question is we want to add, for instance, an element over, so add an element to a set. Now this has no effect if the element is already present. So clearly, because we can't put in duplicates over there, if we add in an element that's already present, then there's not going to be any effect. And you can see that this returns none. So we just have to add it over here. So for instance, if we have 90 over here, the first call set has no 90. So currently, if we are to do a print of first call, we are most likely going to see the first call, and now 90 has been added. Because there's no order in this particular set, we don't expect it to be added either at the first or at the end. It just adds it. Now if we were adding 30, because this 30 already exists in the list, there's not going to be any effect, and that's what we see over here. All right, so you can experiment on your own with different examples, and like I've shown you, I'm not only teaching you what I'm doing, but then how to also go about and become creative yourself and experiment with other things. So this is going to be the end of this video. Like I said, all these things are going to be useful to us when we start building our own applications. Now, if you find value in this tutorial, then kindly support me by subscribing to the Tech channel. Also, don't forget to hit on the notification button so that anytime I release a video, you'll be duly notified. Also, share this video with friends and family who find this content very useful. At Tech, we say learn programming. You can do it. Bye bye, and catch you in the next video.